Hello, lovely humans. Today we are going to talk about operations with functions. Hopefully you've seen this before, and then composition of functions, which is probably new. And then we're just going to practice this skill. So functions, of course, anything we can write in function notation with f of x replacing y, just f of x in its fancy function close. And then we can combine them, we can add them, we can subtract them, multiply, we can do all the types of operations we do with math using functions. Okay, so if we're adding functions together, we're just taking any like terms from the first function and combining them with like terms from the second function. So all we're doing here is saying 2x plus 3, and then we're going to add all of this g of x stuff, 2x squared plus x minus 3. So all I'm looking to do is combine any like terms that I have here. So I have 2x and x, no x squared terms, so just 2x squared. But then 2x plus x is 3x. And then 3 plus negative 3 is just 0, so that's it. So all you're doing is combining like terms, super basic, straightforward, easy. Same idea with subtraction, just a word to the wise. The most common mistake here is that students forget to distribute the subtraction to all the terms in the function you're subtracting. So what I mean is if we're taking f of x and we're subtracting g of x, oh, and I should probably spend a little time looking at the way this is written. So if, right here real quick, we'll go back to that example in a second. F of x plus g of x, that's what we're actually saying when we give you this. So on a worksheet, a question, this would be how it would be presented to you. What it means is just add those two functions together. Add the values, basically just all these things in terms of x, right? So these are the y values in terms of x, and we're going to combine them together. Okay, so same with difference. We're just going to take these two and subtract. So f minus g of x, that's how we read that. F minus g of x means we're going to start with our f of x function, 2x plus 3, and we're going to subtract all of our g of x function, 2x squared plus x minus 3. So every single term inside those parentheses we need to subtract. So I highly recommend you just distribute that -1 or that subtraction to every term inside so you don't accidentally make a mistake. So I'm just going to rewrite it as 2x plus 3 minus 2x squared minus x plus 3. Then I'm simply going to combine like terms like the last problem. No x squared terms, so -2x squared it is. I have positive 2x and negative x, so just 1x left over. Don't need the 1, just x is fine. And then positive 3 for a total of plus 6. So notice the order is going to matter in this one. If I were to take g minus f of x, that would be different. So just pay close attention to the fact that order matters with subtraction, just like it always has. Not so much with addition, right? Same ideas apply, same rules. Okay, f times g of x. Now look at this symbol right here. This is a multiplication symbol, that filled in solid dot. That means multiplication. So now we're going to multiply these two functions together. So I want to multiply these two. 2x plus 3 times 2x squared plus x minus 3. Okay, well, this is going to require a big area model, or at least that's how I would attack it. You could, of course, use the principles of FOIL and distribution. All we're doing is multiplying every term in the first by every term in the second. I prefer the area model. That's what I'm going to do. Let's set it up as a 3 by 2. We have 2x squared, positive x, negative 3, 2x, positive 3. And then we're just going to multiply 4x cubed, 2x squared, negative 6x, 6x squared, 3x minus 9. Now we're just going to combine like terms. Remember, when you're doing an area model, if you set it up in descending order, then all of your like terms will be diagonal from one another. Okay, so we're going to have 4x cubed plus 8x squared minus 3x minus 9. And that would be if we multiplied our two functions together. Okay, now of course we also could divide our functions. So if we're dividing our functions, this, remember, multiplication order is not going to matter, but for division order does, so be careful. We're going to start with g of x, so we're going to take 2x squared plus x minus 3, and we're going to divide by 2x plus 3. Well, you can't simplify this without first factoring. So you want to see if there are any common factors you can pull out of all of the terms on the top or the bottom, numerator or denominator. Or if you see that you have something like a quadratic, like we do here, you want to see if you can x factor this. So I want to see what multiplies to -6, a times c, so a times c here, and adds to 1. Multiplies to -6 and adds to 1. So that's going to be 3 and -2. Of course, divided by our a value of 2. So we're going to get 2x plus 3 times x minus 1. So that is factored form of our numerator there. So we have 2x plus 3 and x minus 1 all over 2x plus 3. Well, that's highly convenient because I have a 2x plus 3 on the top and a, whoop, no, go away, 2x plus 3 on the bottom, and they cancel each other out, leaving me simply with x plus 1, and that's how that's going to simplify. So be careful with function division. Make sure you can't, if you couldn't factor anything out, if you couldn't simplify any further, it could have been left something like this, but because we can factor it and things will cancel out, we need to simplify. So watch out for that, just like you would with normal fractions when you're simplifying fractions. Okay, this is the probably new stuff. This is a composition of functions. So what we're doing is we're going to take a whole function, and every time we see x in another function, we're going to replace it with the entire function. So what does that mean? Well, in this case, this is read f of g of x. And what it means is I want to take all of g of x, that entire function, and I want to evaluate it inside of f of x. I want to replace all the x's in f of x with that function g of x. So totally different than multiplication. Notice this symbol is an open circle, completely different thing. So pay close attention to that. Again, it's always f of g of x. So whatever that last one is, that of course could be h, g, I, k, whatever you want. But that second one, that ending piece, in this case g of x, is what we're going to plug in to our other function, in this case f of x. So let me show you what that looks like. So let's use a little color action here to make this a little bit simpler as well. All right, so if we say f of x is this green piece here, and g of x is this pink bit, and I want to take all of g of x, all of that pink stuff, and plug it in every time I see an x in f of x. Well, fortunately, there's only one, so this one will be fairly straightforward. So in green here, we have this 2 from my f of x function, and then I have that x. So that's when I'm going to drop in all of my g of x business to, oops, why'd you erase? I don't want you to erase. 2x squared plus x minus 3. Okay, so I'm taking all of that g of x, the whole thing, and I saw an x, so I'm replacing it with everything that is in g of x. Okay, and then left from my f of x function, I still have plus 3. Okay, so now we just have to multiply and simplify by combining like terms. So we're going to distribute our 2 to every term inside, and we're going to get 4x squared plus 2x minus 6, and then we have this plus 3 we also need to deal with. So we're going to combine those like terms, and we'll get 4x squared plus 2x minus 3. And that's a composition of functions, so a little bit different than adding, subtracting, multiplying, or dividing. So pay extra close attention to those as you go through. That open circle means something totally different. Okay, I've already taken the liberty of color coordinating these so we could save time in this video and set up the examples for you. So now we're just going to work through these and make sure we understand how it goes. All right, so we have f minus g of x. So I'm going to take my f of x function and subtract all of the terms in my g of x function. Again, remember, be really, really careful with your subtraction here to distribute to all of your terms. So I'm going to rewrite this as 3x plus 5 plus 3x squared plus x minus 10. And that's going to be with my subtraction set up in there. And now I just have to combine like terms. So now we're going to take 3x squared, has no buddies, so that's it. Negative 3x plus x is negative 2x. Positive 5 minus 10 is negative 5. And that would be simplified. All right, now I have a division. I'm taking j of x and dividing by h of x. So again, I've set it up at the top. I have j of x, and then in the numerator, I have h of x. And then I need to see if I can factor this numerator to see if I can simplify any further. So what multiplies to negative 16 and adds to 0? Multiplies to negative 16 and adds to 0. Well, that would be positive 4 and negative 4, right? So the top is going to be x plus 4 times x minus 4. Remember, all we're doing is creating an equivalence here. So x squared minus 16 is equivalent to x plus 4 times x minus 4. That's why we can do this. And then this is all being divided by x plus 4. Well, now I have an entire term that I can cancel out. So that goes away, and we're left with x minus 4 simplified after my division. Okay. Then we have a multiplication. We're multiplying f of x times h of x. We're going to do area model here, 2 by 2. Careful with your negatives. Negative 3x plus 5 and x plus 4. Negative 3x squared, 5x, negative 12x, and this was 5, right? Yeah, 20. Okay, combine like terms, always diagonal if our area model is set up the normal way. So we get negative 3x squared minus 7x plus 20. And that would be our multiplication of functions. All right, now we have a composition of functions. That funky thing, I've set it up and color coordinated it, but I'm going to walk you through it anyway. So in this case, we're given g of f of x. So now we want to take f of x and plug it in every time we see an x in g of x. And this one's slightly more complicated than that first example because g of x is a quadratic function. So now I have multiple places for x's to go in. So notice I had to plug in all of f of x there and all of f of x there because there were multiple places for x. And this one, I'm going to need an area model for. Negative 3x plus 5 times negative 3x plus 5. Remember, we cannot just distribute that square. That doesn't work because you're eliminating that middle term when you do that. So we can't do that. So we have to actually do our area model here. So we get 9x squared minus 15x minus 15x plus 25. So just this little part here, right, is 9x squared minus 30x plus 25. Okay, and then I still have to distribute that negative 3, which came from my g of x function. Over here, I need to distribute this negative to both of these, and then I have to combine like terms. All right, so negative 3 distributing this again, going to become positive 3x minus 5, and then I still have that plus 10 at the end. I'm going to stop here, assume that you can distribute and combine like terms, but double check that you can. Let me know if you can have any troubles with that. All right. Now you're going to pause if you're watching this on YouTube. Make sure you're attempting these yourself. Hopefully it's working in Edpuzzle and I've paused it for you. But attempt these yourself. Make sure you know what you're doing. So we're going to start with f of x, negative 3x plus 5. And we're going to add it to g of x, which is negative 3x squared minus x plus 10. Simply combine like terms here. Negative 3x squared minus 4x plus 15. Whoop. And we are done. Now we have a multiplication, h of x times j of x. So we have x plus 4. We need to multiply by x squared minus 16. Area model it is. x plus 4 times x minus 16. We're going to get x squared plus 4x minus 16x minus 64, x squared minus 12x minus 64. All right, hopefully you're doing okay. G divided by f of x, so we're looking for our g of x function, which is negative 3x minus x plus 10. And we're going to divide by our f of x function, negative 3x plus 5. Okay, remember you want to try and factor this because so far you couldn't simplify. There are no common terms shared by every single term here. So we need to see if we can factor our quadratic. Oops, that's squared. Okay, so we are going to see what multiplies to negative 30 and adds to negative 1. Sounds like a 6 and 5 combo to me where the 6 is negative. So we're going to end up, again, don't forget to divide by that 3, which was our a value. So we're going to end up with x minus 2 and 3x plus 5. And that doesn't simplify because I have negative 3x plus 5. What would we do here? So we could have taken a negative out in the beginning and done negative and had a positive 3x squared. Oh, because I didn't take my negative there. That's what happens. This is positive. This is negative. Okay. So this would be the same as a positive, and that one's negative, 3x minus 5, right? Those are going to cancel, and we're going to be left with x plus 2 as our numerator. Hopefully that wasn't too confusing and you had done it on your own already, so my mistake didn't impact you. Okay, h of x going into j of x. So we're going to take everything we see in h of x, and we're going to plug it in every time we see an x in j of x. All right, so h of x, what was that one? H of x, so we're going to take x plus 4, and we're going to plug it in place of that x squared in our j of x. So we're going to take x, what did I say, plus 4. We're going to square it, right, because it's going in for, and then we subtract our 16. So again, we took h of x, this x plus 4, and we plugged it in to this x over here. And then we need to do an area model. X plus 4, x plus 4, x squared plus 4x plus 4x plus 16, x squared plus 8x plus 16 minus 16, and we're left with x squared plus 8x. All right. Hopefully that made some sense and wasn't too much. Make sure you let me know if you have any questions, and we will get it sorted out. Hope you're having a good day.